Microservices can be defined as a software development technique that structures an application as a collection of loosely coupled services. Each service is designed to perform a single function and communicate with other services through a well-defined interface using a lightweight mechanism such as an HTTP-based API. Now, when building more sophisticated applications, we often need to perform complex operations that span multiple services. For example, when a new alarm is created, we might need to first parse the obfuscated alarm data coming from an external system, then pass it to the AI-driven alarm classification service to classify the alarm, and finally pass the classified alarm to the alarm notification service to notify other services, or perhaps a user about that alarm. In this use case, we need to come up with a way to coordinate these services and define the order in which they should be executed. There are two common approaches to this problem: orchestration and choreography. Let's take a look at each one of those in more detail. Orchestration is a centralized approach to service coordination. In this approach, we have a central component called orchestrator that is responsible for coordinating the execution of services. This orchestrator is aware of the state of each service and knows exactly when to invoke each service. The orchestrator is also responsible for handling errors and retries. Note that this orchestrator could be implemented as either a separate service, or it could be part of one of the existing services. To better understand how orchestration works, let's take a look at the following example. In this code snippet here, we can see a simple orchestrator that is responsible for coordinating the execution of three services: parse alarm data, classify alarm, and notify. Each operation is represented as a separate function, presumably calling another microservice under the hood. The orchestrator is responsible for invoking these functions in the correct order and, if needed, handling any errors and retries. One of the main advantages of this approach is that it's simple and easy to debug. However, services are tightly coupled to the orchestrator. On the other hand, choreography is a decentralized approach to service coordination. In this approach, each service is responsible for handling its own state and knows exactly when to invoke other services. The services communicate with each other using events. The main advantage of this approach is that it's more flexible and scalable. However, it's also more complex and harder to debug. Each of these approaches has its own pros and cons, as there is no one-size-fits-all solution. In some cases, orchestration might be a better choice, while in others, choreography might work out better for you. It all depends on your specific use case. In the next lesson, we'll implement the orchestration approach in our application, but just always remember that this is just one of the possible design choices.